So we try and look at our lovely function. It's a cubic given by the highest power of x, or the highest exponent. And of course, this guy has, on this picture, two turning points. A local maximum, a local minimum. Also called vertex, vertex, turning point, turning point. But let's go and find the actual equation. The question asks you to do it using simultaneous equations, forming simultaneous equations. Just have a look at my extra explanation. Always just say what you're doing. When x equals 3, y equals 1, and when we substitute, we get this. Using x equals 4, y equals 5, we substitute and we get this. Always good to signpost what you're doing. I solved down here, but I'm going to delete this because I copied it from my calculator, and I'm going to do it again, but using the spreadsheet method. So go and get the TI Inspire, open it up. We are going to go doc, insert a spreadsheet. I'm going to put a little X here and a Y here. We're going to shift it on. This is now X and Y, 3 and 1, and 4 and 5, and finally 5 and 3. We'll work on this menu now. Menu, statistics, stat calc, and we'll go to cubic regression. We have to tell the calculator X and Y, and the reason I've done it here is because of this. Look, we're already storing the equation on the graphing menu as F1. So we press OK. Dimension error, not enough elements in the lists. So what's gone wrong? Why is there not enough elements?
It's a cubic and we need 4.
It's a cubic and we need 4 points, right? So the reason why this won't work is 3 points here, I would fit the perfect quadratic through it, but I need a 4th point here. Now let's go back to the equation. We can always find that 4th point. Can you see how? What if we make x equal to 0? But then y would equal to d. So how can we find a 4th point? We actually can't find a 4th point on here, can we? So who did the spreadsheet method for this question before? Anybody? The reason is we can't. We can't use the spreadsheet method for this, all right? So unfortunately, that means we have to use the simultaneous equation method. Yeah. So 4 points defines a cubic. We've only got 3 points given here. So it's not going to work. But that's absolutely fine. Let's switch out to the simultaneous equation method. And I've done it here already. I've got the answers. This is the B, the C, and the D. So we are going to go doc, insert a graph, and shout out to me. It's 2x cubed, right?
Minus 27x.
Thank you. Minus 27 times x squared plus 119x. And then finally,
Minus 176.
176. 167, yeah, thank you. And that kind of looks about right, doesn't it? Sort of looks about right. Beautiful. So we are going to finish off this question now with E, the decreasing part of the graph. So the decreasing part of the graph we have to get right from going menu, analyze graph, maximum, which is here. We put the numbers to one side, menu, analyze graph, minimum. We could have done a graph trace as well. And we need to pick the x numbers, right? Between 3.85 and 5.15. We have to make that with an inequality though. Yep. So the left-hand side, the right-hand side, x in the middle, and the nice little inequality signs opening up. One day the ride stops at the highest point. Oh, we've already got the answer. The highest point is the 5.08 meters. Okay, so we have to pick the right coordinate. And the final thing is this one. At night time, and Dominic, I'm going to change this with your suggestion. The ride will have special lights that turn off if the ride goes higher than 4.5 meters. It makes it scarier. It's higher, it's dark, it's scarier. Write down the domain when the lights turn off. This won't change the answers that you've already got, because what people forgot to do, I think, on this is menu, graph entry, function 4.5. Boom. That's the height of 4.5. Now you can clearly see from here to here, the ride goes above 4.5 high. And from here onwards, the ride goes above 4.5. So we have to find these intersection points. Sometimes if I want to zoom in on part of a graph, menu, window zoom, zoom box. Love it. Click, drag out the section of the graph you want to zoom in on. I love it. As soon as you've used the tool, press escape, and then you can start to move things around by holding down the hands and just clearing things out so you can see it nicely. Finally, menu, analyze graph, intersection, click before, click after, go and grab, move to the side. Menu, analyze graph, intersection, click before the intersection, click after, grab and move. Finally, menu, analyze graph, intersection, click before, click after, and just move it. Let me show you the final answers, how it will look. We want the domain from here to here, and we want the domain from here onwards. The domain is X values. I will do doc, insert a notes. So domain, we'll go back here. We need the 3.5 for this guy, and then the 4.29. So we want 3.5, 4.29. We put X in the middle, and then we surround it by the inequality signs like this, opening up from smaller to bigger. And we have X greater than that other number, which was this X number, which is 5.71. So that's the final answer for that lights bit. You're welcome. Have a lovely weekend.